In this video, we're going to take a look at a machine learning technique called k-nearest neighbors. So with k-nearest neighbors, what we're trying to do is either classify a categorical outcome. That's where we either are mapping to a series of strings or a series of whole numbers, or predict a numerical outcome, so a continuous outcome. What we'll do is we'll plot known data, and then we'll classify a new record by plotting it against the known data and see who the nearest neighbors are. So finding the nearest neighbor, oftentimes we'll use Euclidean distance. If you remember the Pythagorean theorem from back in high school math, where the height and the width squared equals the hypotenuse squared. So take the square root of that to get the length of the hypotenuse. And that's effectively how we will evaluate a k-nearest neighbors plot. So there are a couple ways that we can find the nearest neighbor. One is just k equals 1. Who's the nearest, period. The other option is to kind of take a survey of several near neighbors, and in that case we'll say k is greater than 1. We'll usually make it an odd number because if we're looking at a categorical outcome, we don't want to have a tie where, if there are two categories and 4 different k's, 2 and 2, it could be a tie, but 3, that'd be less likely. And usually we will choose a k between 1 and 20. So let's go ahead and jump right in. The example I'm going to use is classifying counties in Oregon. So Oregon tends to be a very binary state. The counties on the west tend to be very different than the counties on the east in many respects. Counties on the west, you have Portland up here, which is the big city, and then the counties on the east are more rural. Politically, there's also a divide, and we have election data that has a good amount of demographic data. And so I'm going to use 2 data points from that election data to say, okay, here's how we can plot counties in Oregon. One will be age under 29%. Another will be total population. And then I will color the points on the chart based on how that county as a whole voted. Because what you'll see on this great divide is a lot of it you can see is political, where you'll see a different voting pattern in the east of the county than you will in the west, or east of the county than you will in the west of the state. So I have here a Jupyter notebook. I have the imports that we'll need. And then I took the election data that I used in a few previous videos, and this time I trimmed it down to just Oregon. So next I'm reading in the Oregon subset of the data, which I put in its own CSV, setting the index to county. And you can see again we have the election data and the demographic data that we've used before. I'm going to take just the bottom 30 counties. There are about 34 counties in Oregon. I'm going to separate out the bottom 30 counties and the top 5. I'm going to do train and test on those bottom 30, which you see here. So starting with Coos County, ending with Yamhill County. Next, I do our train test split and give it a test size of 0.4. Actually, given that we don't have a whole lot of data here, I'm tempted to crank that up a little bit or make the training size a little bit bigger, but we'll go ahead and stick with that. Now, for those top 5 counties, I'm simply putting them in a separate data frame. And now, I'm going to do plotting, which is a lot of how we'll do k-nearest neighbors. This little thing right here is really handy, this matplotlib notebook. That gives you a toolbar that you can use to zoom in and out on the plot, which is really handy in this case because we'll often see a lot of dots that are clustered together with each other. Now, I mentioned in a previous video that I have a rule, I don't talk politics in class, and there's several other things that are topics that I put to the side. So in a previous example, I looked at third-party voting percent and also Trump voting percent. So this time, we're going to take a look at counties that voted for Clinton. And again, not making a political statement, it just happens to be a data set with a whole lot of really good columns that I can use. And in this case of the Greater Idaho movement, it happens to be a relevant factor as well. In this case, we're just classifying it as effectively as a blue county if Clinton got more votes than Trump in 2016. And that will give us a categorical column. over to the right, so you can see a simple column D, county voted for Clinton more than Trump, or blue county, however you want to call it. But here we just have this column called D. Okay, now let's go ahead and plot our data set. So this is a fairly good sized function that we're doing here, but we start with the function we're defining here. Plot the data set. Let's take the axis, the data we're plotting, the label, and then any other arguments that would come in effectively as name value pairs after that. Now, as we're looking through the data, if the data has the D column set to true, and remember that's that column that we just made up here that just says were the majority of the votes for Clinton in 2016, or at least were there more for Clinton than there were for Trump. We didn't worry about third parties in this case. If so, we're going to use a marker of D and label as a Democrat. If D is false, then we're going to say, okay, well, this is a red county. Marker O, marker style O, and Republican. And then we're saying the two things we're going to plot are the total population of the county and the percent of residents that are under 29. So we're looking at this saying these are two features that might be a good way to distinguish those that are interested in joining Idaho and those who are interested in staying part of Oregon. Now, we plot the two data sets here, the training data and also the testing data, so we can see how close the testing data came to the training data. Let's go ahead and see what this gives us. Okay, so I plotted training and testing data as two different colors here, which will be a little bit interesting. But then also those extra 5 counties that I pulled off earlier, I went ahead and plotted those with a star, with a black star down here. So I kind of did 2 steps in once here, because started with the train data, and then really we could look at the test data on top of that and say, okay, how close did this come? But then I also added effectively 5 new counties after the model's created to say, okay, now how would we classify these counties? Nonetheless, let's take a look at what we have. So Washington and Multnomah County looks like that was part of our testing data set. And both of these counties are Democratic counties, ones that voted heavily for Clinton. Multnomah is where Portland is located. The nearest ones to this, ignoring Clackamas, the nearest one is Lane County, which is also a blue county with high population and about the same percent under 21. Incidentally, Clackamas also very similar characteristics. Clackamas County borders Portland and tends to be a bit of a younger, more urban county, and also tends to vote blue. So far we're saying, okay, well, these look fairly common. Now, Marion County, I can't explain. Marion County, that might well be an outlier. But nonetheless, as we do get into the lower population here, we see the circles, which represent Republican-leaning counties, and we see that those indeed do tend to be clustered together. Now, you remember a moment ago I had that matplotlib notebook line, and so that's what gives us this capability to pan and to zoom in, so we can pan like so. And let's see if we can do it. I'd like to just zoom into this guy a bit. Although, there we go. That's right. You have to draw a little box. So now you see if we draw a little box, we can say, okay, we take a look at the counties in this lower population cluster. Many of them are Republican-leaning counties. Hood River is an exception there. But otherwise, the new counties that we've plotted here, so Claston, Columbia, Baker, if I were to do a K nearest neighbors with 1, it would almost definitely land on a red county. With any odd number, 3, 5, anything else like that, all of the surrounding counties are red counties. So, or at least the vast majority of them. So we can see that this K nearest neighbors lets us take a look at 2 characteristics, in this case population, which is kind of a proxy for how urban it is, and also the average age of the county. And see, does that tell us something about another characteristic, which in this way is the political leanings of the county. This might be interesting to use, thinking of a real application for this. This might be interesting to use if you're a national candidate. Let's say you're governor of a state and you're running for president or some other national office, and you know how your state has voted for you county by county. Now, can you take that and can you extrapolate that across the other 49 states and be strategic about where you do things like fundraising and campaign visits and stuff like that? So train the data based on the counties in your state and then apply that model to counties in other states. And of course, there are state-by-state variations as well. So Vermont, you'll tend to find a lot of lower population counties that tend to vote blue. Nashville, Tennessee, Fort Worth, Texas, Miami, Florida, you tend to find urban counties that vote more red than usual. So there are certainly exceptions there, but nonetheless, that's a practical application for this model. Now, we can, incidentally, we take a look here at the New Oregon counties, and we can take a quick look at how they voted. Looks like this one was solidly red, this one blue, this one blue, this one a little bit blue, and this one red. So we've got kind of a mix on those counties that we pulled off. Now, we can do this we can do it as a graph. We can also use this k nearest neighbors function here to do it computationally as well. And we can pass in something like our new counties and say, okay, well, who are the nearest neighbors to this county? So if you take a look at what we did here, so we want to predict, is it a blue county? And we're taking the total population, age 29 and under population. We're doing our scaling. So subtract from the mean, divide by standard deviation to put everything on a similar scale. And now we're creating our training data. And next what I'm doing is making just a really quick and dirty data frame with one of our new counties, probably Benton County it looks like, since I did lock 1 there. And I take that and I pass it into this k nearest neighbors equation here. And I say, okay, I want you to look at the 5 nearest neighbors, and then I want you to tell me who the 5 nearest neighbors are. So in this case, the 5 nearest neighbors are Morrow, Lynn, Lane, Harney, and Wallowa County. If we're looking at the political leaning, one is a blue leaning county, the other 4 are red leaning. So if we were to take an average of that, we'd say, okay, this new county that we found is likely going to be a red leaning county based on the characteristics that we found. So that's a look at k nearest neighbors. As always, I hope this video was helpful, and I look forward to reading your comments. Thank you.